Get started. Yep. So, so far we had this overview about a whole lot of different technologies that are available right now on the ASP.NET and the web development in general. Some of them are Microsoft, some of them are open source or whatever else, but I think we have been showing how we can put these things together and run in our platform. Then we had a great overview of ASP.NET Web API. And I will talk a little bit more about what happens when, okay, you have your website, it's running there now, changes happen, you have scalability problems, and you have to deal with those scenarios. So hopefully it will be kind of a fast-pacing presentation to show some good ideas that you may want to consider when we start having all those typical challenges of everyday maintenance of your website and so on. Before I start doing that, I wanted to just show a improvised thing based on what you just saw in the Web API. You may not know this, but another way of creating a Web API and hosting it is just like you saw before, I create a new website, a new web application, but this time I can choose a mobile service, right? So Azure Mobile Service works like a layer on top of ASP.NET Web API. And being a layer on top of Web API, it gives you a few additional benefits that you don't get easily out of the box. You have to write a lot of code to do that. And I just want to kind of really briefly show you some of these benefits, this overview, because it can really help. Well, so it's downloading a bunch of NuGet packages, and you're going to see that actually it downloads more packages than the typical Web API application. So I'll just run it to show you some of the things you get out of the box. The first one is, remember in the previous presentation you saw, hey, I can download this NuGet package that helps me to test the Web API and can see if the methods are working, and I have this on the browser. So this is already built in here. I can just say get, I have a to-do item table that he created as a sample for me. If I click at this, I get a description of how the call works, and I can try this out. I can actually write the headers, the body, the call, execute that, and get the result back. So that's benefit number one, right? You get this thing out of the box without having to do anything. The second thing you get out of the box is you get push notifications. So if you need to send push notifications to iOS, Windows, Android, it has this centralized API that does that for you. So you don't have to go work in those APIs one by one. So that's another great thing. There is another interesting benefit. Like if I go to the Azure portal and I publish this Web API, let me see if I have one here so I don't have to do it from zero. If I publish this to Azure Management Console, the assumption is, okay, you're creating these Web APIs. Next logical step is you're going to build some mobile application. And you might be building this mobile application on Android, on Xamarin, cross-platform, Windows 8, I don't know. So probably that's the next thing you're going to do. So you know what? This is one Web API on mobile services that I already published. So if I go here, it gets some starter links for me. So for example, I want to create an iOS app or a Windows Store app. I can say I already have one, or you create one. I choose the language, and I can download a zip file with the Visual Studio project already hooked up with that Web API, with the calls, so I don't have to start from zero, right? So that actually helps a lot. It saves you from all that initial plumbing work that takes several hours of setting things up. So that's another great benefit you get here. Another very interesting thing it does for you is mobile services gives you all the code to work offline. So if you're building a mobile application, the very likely thing you have to do is sometimes you lose your connection, then you have your connection back, now you lose your connection again. So you have to work with data offline, change things, and then when you're connected, you send the data back and update the service. It does it for you, right? So you can just say, I want to work offline now. It has SQLite on your whatever you use, or iOS, Windows 8. And then it will do optimistic concurrency when it's able to connect and send the data back. So if nothing has changed since you got the data, things just work. If something has changed, then you're going to get an error, and then it's up to you to decide what you do with that error, right? Someone else went there and changed something before you. So it does all that plumbing, so it saves a lot of work. Another benefit you get from mobile services is you don't have to do it in .NET. If you don't like Visual Studio, if you don't like .NET, you want to do Node.js, that's an option as well. You can go to the website and say, I'm going to create a mobile service in Node.js, create my entities, and you script everything in JavaScript. So still the same functionality, just a different platform. So I just wanted to highlight this is also an option. So if you're doing mobile ASP.NET Web API, that's something to consider. So let's go back to the what I was going to talk about. The first thing I want to talk about is scale. One thing to consider is, although Azure makes it very, very easy for you guys to auto-scale your site, your application, you have to be careful about, are you sure you have optimized it enough before doing that? I think Bill Gates has this famous quote where he says that if you automate a bad process, you're going to get a very big problem, right? But if you automate a good thing, then you get lots of problems solved, right? So if we start making it easier for your website to create multiple instances in Azure, but you still haven't figured out how to optimize it, chances are you're going to get yourself in trouble and with a very big bill. Like, we don't mind, but you should, right? And so I think the first thing I'll show before showing the auto-scale things, because those are the easiest ones, is what are some things you should consider when you are dealing with optimizing, making it faster. Like, typical scenario is your database is deadlocking, right? And you start adding more instances and that doesn't work, like it doesn't make things faster. Actually, more likely it's going to make it even slower. So it's important to have awareness of those things before say, hey, Azure solves all these problems for me, let's just create more instances, right? It's, it doesn't work like that. When it comes to auto-scale, there are different patterns. One thing is, I have a website that has a specific date, a specific time where I will need more processing power. I know that. It's well known. For example, I sell tickets for the Soccer World Cup. Yes, I will start selling that on Monday. Likely, people will just jump on that website like crazy at the time I start selling it. So I know that. I can even make an educated guess of how many people will be there, so I can prepare. And that's a good problem to have because we know what's going to happen. The other scenario is I just don't know. It just happens. You have a marketing-focused website or some social media or something. Suddenly something goes viral. Suddenly people start sharing content. Someone likes a lot something you put in there. Out of the blue, in the middle of the night, your website crashes, right? And you didn't prepare for that. You had no idea this was going to happen. So I think for those scenarios, there are different configurations we can try out, and I'll show a little bit of that as well. So let's talk about optimization first. One easy, I'll say low-hanging fruit you can try out is offloading bandwidth from your application web servers, right? If you have web servers where your code is actually running, you have dynamic content being generated, ASP.NET MVC, Web API, so on, likely you don't want to share that bandwidth with stuff that you could offload to other servers. So, for example, I have a little website here, so the same sample you guys saw before, the Geek Quiz. So I have it here. And what happens is the first time I load this page, I have to log on first. It loads an image. Well, so that image is not dynamic. It's always the same image. It's always there. And there is no reason why that web server, which is the application server, which is busy delivering dynamic content, has to also deliver that static content, because that could be distributed somewhere else. Actually, would be even better if different browsers from different regions could get this image from different places that are closer to where they are. So I'll register my user here. And I will, oh, I already have the user. Let's see. Oh yeah, of course, I ran that before. So, so one trick we use is we can tell ASP.NET MVC to, as a request comes that follows a specific pattern. I don't know what's going on here. Let me. My database is being recreated right now. As a web request follows a specific pattern, we can take that, look at it and say, hang on, I know this pattern, and I know it has no server-side processing required. It's just a file. It's just an image or a JavaScript or something else. I don't need to really get this web server busy with this content. So if I log on here, there you go. So this little image over here, right? There is no reason why this web server has to deliver it. If I have web browsers across the world, I could actually have different web servers that only deliver static content to those browsers without having to bother this application server with that. So there's a little very simple trick to deal with it, which we have here is we go to the web config. And let me see if it's large enough. We create a rewrite rule, right? That basically says whenever you find a URL that has this emj/something, you're going to create a redirection to somewhere else, right? So replace that with this / the same file name, right? So what the web server will do with this configuration is telling the browser, this thing you're asking me, go get it there, right? Go get it somewhere else. And if you notice, this URL is actually pointing to an Azure blob storage, right? So what happens here is that when this runs, if I enable, for example, Fiddler or F12 tools on the browser, I can actually see that the web browser is still asking the image to this server, but the server is redirecting that with HTTP status to redirect and saying, don't ask me this anymore, go ask this there, right? And now you can mix this strategy with content distribution strategy. So you can actually say, depending on your region, depending on where you're coming from, I will show a little bit of that as well. Let me debug that here. So you see that if I debug this, let me enable network filtering on this and doing a refresh. So you're going to see that the application is asking for the image locally, but it's getting a 301 back, right? And so the web server is saying, not me, go there, right? And if I look inside this response, I will see that actually response header, I can see that's actually saying, hey, go get it here, right? So the next thing the browser will do, if I go back to the summary, is saying, all right then, and we'll go there to get it, right? So I just offloaded a whole bunch of stuff from that web application server with a very simple setting, and that's pretty cool. The other interesting thing you can do is once you publish this as a website, so I have the same web application here as a website, so I have already published here, right? And I have it configured as, no, scale. I have it configured as a standard web hosting plan mode. And what standard gives me is the ability of configuring auto scale, right? I can tell not only the size of the instance, so I can scale vertically with a bigger box, right? But I can scale horizontally, saying, hey, I want to create a schedule time. So for example, I can set up different schedule times for different settings. So I could say, for example, for the day, do this setting, for the night, do this other setting, because I have different load patterns or difference between weekdays and weekends. This is my pattern. Or I can even specify dates, right? During this date, do this setting, right, in this date range. But basically, what this gives me is the ability to say, on this particular date, I want to apply the following settings. And the settings could be either fixed, right? I want these many instances running at that time. Or I can set up a CPU-based target where I say, if anything goes below 30%, you're allowed to decrease the number of instances. If anything goes above 41%, you're allowed to increase instances up to this much, right? So you can define ranges. Now, this is the portal that most people are used to use. That's the Azure portal that we call the Manage Console. What we've been talking about recently is the new Azure portal, right, which is a portal.azure.com. And that one is going to offer a few more options. I want to show them a little bit before I run a test and let you guys see that working. So the new portal is gradually, so it's still in preview mode, so it doesn't offer everything the normal management portal does. But the idea is that it will gradually embrace everything and way beyond with more settings. It's highly customizable, so you can right-click things and say customize, and you can mess with tiles and change them and configure what you want in your front screen. So it's very handy because it respects your personal preferences instead of enforcing one single view to everybody, right? But what I will do here is I will browse that same website I was showing before. So I have websites here, and that's this website I just published. And I can see here there's more or less the same settings, but with a few more abilities here. For example, if I go to scale, so there is a scale here, it's telling me there is one instance right now running. So I will load this here, and it will tell me how the usage pattern has been doing, right? How many instances have been running since a few days ago. You can see yesterday there was a little boop, and then back, right? Because I was testing what I'm going to show right now. And I can create additional rules here. So this is similar to what I showed before. What's different is this thing here. I can create scale up rules and scale down rules. And I can use more metrics than just CPU, right? Maybe the thing that tells you you need another instance is not CPU, it's memory. Maybe it's how much data is waiting to be received and replied to, right? So you might use different metrics, right? Because maybe what's holding your scale is not necessarily the CPU. Again, careful with that. Make sure you know what is it that's your bottleneck before you start putting 20 instances there, because if you don't know, chances are that's not going to help you. But this is really cool because it adds more features. Another interesting thing it lets you do is you can control how much time you're actually using to look back and make that decision. Like when I say CPU goes above 40%, create a new instance, goes above 40% after which time window, right? What's the average you're using? In the old portal, you didn't have control for that, so I think the default was 45 minutes, right? So it was actually hard to demo these things because, I mean, I had to actually make sure that the average for the 45 minutes would actually go above that threshold so I could trigger the creation of a new instance. And now I can actually control not only how much time, but also the cooldown time before I make another decision, right? So all these things are configurable, so I can actually have better control of how I create more instances and remove them. So this is how it's configured right now, right? I have these thresholds. I'm saying it can go up to 3 instances, and I'm looking back at 5 minutes. So what I would do is actually do some performance test on it. So I have another Visual Studio project, which is a stress test project. So you can go to Visual Studio, File, New, and you can create a web test project. And when you create a web test project, the first thing you do is creating, if I go to Visual Studio, I have a web test. I can create several web tests. And the web test is a sequence of instructions about which kind of HTTP requests you want Visual Studio to do simulating a browser. So in this particular case, I have one, which just goes to the home page, right? You say, call this thing, call this URL, right? And I put in this inside a loop, right? I can create several tasks here. I can add requests, I can add loops, conditions, I can do a bunch of things here. So I'm adding a loop and saying, do this 1,000 times, right? Count to 1,000 and keep sending these requests over and over again. But that's not enough, right? Because that's a single thread. So you keep doing that one by one, one by one. That doesn't necessarily force the web server to really work hard. So what we do is once we have the web test done, we can create a load test. So there is another test here, which is a load test. And in the load test, we actually say, I will run that web test, or a collection of web tests, and then I can control, for example, simulating which browsers. So in this case, 100% IE10. I could do like 50% Chrome and 50% IE or whatever. I can decide how this distribution is going to work. The load pattern, I can actually define, do I want to simulate a lower bandwidth here, or just learn, like don't throttle anything, just send requests as you can, or simulate you're doing this from a mobile device where your bandwidth is limited. So you can control this distribution any way you want. And you can tell what data you want to collect back, right? Not just from the server, but also, and equally important, from your testing controller and agents. Because often what happens is you do a load test and you think, oh, I'm reaching a bottleneck here. You're not. It's your client machine that's not handling that. It's not the server, right? So you need to know that. Say, okay, there's something wrong here. And actually, on that, an interesting thing you can do is you can open your load testing. And you can say, you know what, I don't think my laptop will be able to make that server even blink, right? It's not enough over Wi-Fi. So why not asking Visual Studio Online to actually pop up some instances on the cloud to hit the web server for me, right? It's another great advantage of cloud computing is that you're going to run a load test for a very short time range. At that short time range, you need a lot of instances to do that for you. Then you can just get rid of them and go back to your. So I don't need a super powerful computer data center to actually run this load test, and that's really helpful, right? So I have all of this here. So what I do, I just run this load test. So I just click here, and it will start. First thing we do is that we will connect to the my Visual Studio Online, which is taking a little while, so it's not initializing it. It's putting my requests on Azure, on the Visual Studio Online, say, can you please book these resources for me, right? It tells me the position for my request in the queue. So in this case, this Visual Studio Online is just me, so there's no one else. I don't have to wait for resources. It should start right away, right? And I'll leave that running there so I can come back to this later and we can see whether this works well or not. So it's an interesting, you can even say, this is the Visual Studio Online account it's using. So I can control that. I can tell, use this particular Visual, if you have multiple accounts, maybe you have one just for load tests, so you have that sort of control, right? So it's interesting. And you can see that right now it's taking a while because actually bringing those instances up so I can simulate those. I think my configuration right now is 500 users or something. So it will take a little while to run this test, right? So this is all good. What I have next here, I think I already showed this. The other interesting thing you can do is traffic distribution. So one of the new things on Azure that got a little bit more powerful now is the traffic manager. The traffic manager is a way of distributing requests across multiple endpoints. And the traffic manager has three basic ways of working. One, the simplest one, is failover. So basically give it two endpoints and say, always send the request to this one. If this one goes offline or it doesn't respond, you send request to the other one. There's no load balancing, there's no intelligence there. It just offers a failover option for your web requests. The second option, which is a little bit smarter, right, but it's still really random. The idea is you get a request and you go like a mini, mini, mo, go here, right, and send a request to one of your endpoints. And you can have a series of endpoints there, but again, there's no intelligence to say, well, I think this request from Japan should go to this data center here. It doesn't know that, right? You just send to the first server that we'll see. But you still have the failover option. So it will still be smart enough to say, I'm sending requests to this endpoint and getting no responses. So let's assume this thing is down and start sending requests somewhere else. It does that for you. There is the third option, which is a bit smarter, which is the performance option. The performance option, the way it works, it tries to measure the distance between your request and those options of endpoints you have there. How does it measure that? It's basically looking at how many hops, right? It's not doing anything super fancy like looking at average request response time, nothing like that. It's just saying, well, this request from the United States, it looks like this website that's right there in New York is more likely going to answer that better, so let's just send it there, right? Oh, this other one in New Zealand is more likely going to be answered here in Australia. So it just does that. It will not, one example where this is not going to help you, you have a website in Asia, another one in the United States, and in the morning in the United States, everybody wakes up and goes to the website, and the website is overloaded, the other one is there sitting idle, but still the traffic manager doesn't know what to do about it, right? So it's still looking at distance only. And that's when you combine this with auto-scale, with content redirection, and all these other options where you can make most of it. So basically, those are the three options. This one also has the failover thing, so you also have this option right there. Let me see just how my test is going so far. So it's starting to collect some data. It's 2 minutes away. I don't think the auto-scale would have happened yet, but let's do a refresh here, just in case. At some point, we should see a new instance showing up, right? It won't go all the way to 3 instances because it's just 5 minutes, and I told you to just do one thing every 5 minutes, not 2, so it's not going to jump all the way to 3 instances from 1. I could have configured that as well. So usually, you don't want to react too fast. It depends on your scenario, but usually the practice, you really want to take a little while before you make a decision like that, because if you keep bringing instances up and down all the time, you're going to waste a lot of time with just doing that, instead of actually taking advantage of what you're doing. So you got to be a little bit careful with that. But in our case here, it's still loading, so let's leave it there for a while. I'll come back to this later and see how this is doing. So we have a traffic manager, and we also have scenarios where we need to deal with database changes, and that's an interesting thing, right? Typical problem, you're deploying some code, some binaries, but you're also deploying some database changes. And those things have to be very well coordinated, because if you mess with one, the other one won't work, right? So how do you balance that? There are some interesting things you can do about it. So for example, you guys saw already in the previous presentations how we, let me open this sample here. You guys saw how we create a ASP.NET MVC with a database, and you can actually create model classes, right? That's the same Geek Quiz example, so I have some model classes here for the question, for the option, and so on, right? So if I run this, because that's the first time I'm running this particular solution, it will call my Visual Studio and say, hey, you don't have any databases created locally, so create one for me. Here's the model. do this for me. So the first step is always tends to be the easier because there is nothing previously there in the database. I'm just creating everything from zero. So that's the risk of introducing a change here is very small. The problem is after that, right? So you publish your database, you publish your website. Now you're gonna. There's already a database there. I'm using the other one. Okay, fine. So still. Whoops. Still, now I want to create a new column. I already have the database. Okay, let me delete this database. So the thing is, the way this works is it looks at your model classes and it looks at your database locally, right? And those things have to match. If there is one column here that I don't have here, it's going to say, whoops, there's something wrong there. And that's exactly what it's doing here because I ran this before and I didn't delete that. So it's looking and say, well, there's another column there that it's not here. Like, what do you want me to do about it? So I will solve that in a very simple way. I will just delete it because I don't care. I just want it to create again, right? Sorry? Yeah, sure. So I went to Visual Studio, right? I went to my Server Explorer, my SQL Server, right? I found the database that I know that I'm using, and I just hit delete. Just say delete that. So Server Explorer lets you talk to your local servers, to Azure, right? I can talk to the. I don't know if you guys saw that, but I can even create virtual machines all the way from Visual Studio, right? I can right-click here and say, go and create a virtual machine for me because I need to publish this website. So I can do almost everything from Visual Studio without having to go to the Azure and messing with Azure. So what I did was deleting my local database so that, in theory now, I should be able to register. Let me see. And it takes a while. And it's taking a while because now the first time the code runs, Entity Framework looks and say, okay, you don't have a database, right? So it means I have to create everything for you. So it starts creating the database, adding the data. So now it works. So now that works, what I would do is publishing this to Azure. So I right-click on the project, right, and say publish. And then he asks me, well, how do you want to publish this? I could say, for example, I want to publish this into a virtual machine. I don't want to run this as a web site. I actually want you to install Windows in a VM, boot it up, and put all the code there. I have that option as well. But I don't want that. I just want a website. So now it's going to ask me, well, there are a bunch of websites there. Do you want to install in any one of them? And what I will say is, no, I want to create a whole new website with a whole new database. I'll call this something like that. Then I can choose the region, right? So I can say, well, in this case, I want to install in the whatever, West Europe. I can choose the database server. So I have 3 different database servers there. There is one at West Europe, whatever, let's do it here, right? Because I already have a database server, I need to give the password for it. So database server, password, create. And what it will do is create a new database for me there. So this web application can be published and talk to this database. And then I will publish, once that's done, I will be able to say, publish this website, and it will publish the website. So there you go. It knows everything it needs to know. This is the URL where this website is going to run. Publish it. And it's going to take a little while. While it does that, let's see if our auto scale works. So let's F5 here. So remember I was running my little auto scale thing, right? The test is done, so it shows some data here that it collected about response times. You can see the response times were getting slower, right? Now we can see whether it actually created a new instance. Let's see if it loads. My connection is a bit slow here, but hopefully. Loading, loading, loading. Loading. Oh, there you go. Look at that. There are 2 instances running now, right? Why is that? Because we hit it enough, so that threshold we configure say, I probably should bring another instance up to respond to this guy, right? So that was the whole idea. And if I leave it quiet for a while, after 5 or so minutes, it will come back to 1. Okay? So let's close this because I don't need this. Actually, I'll leave it there. So I just published my website, and it's running there on Azure. And just to make sure it's running, let's see if I can register here. So now I have to register again. Why? Because it's not my local database anymore. It's a database right there in the cloud. So I register, it creates a user, and if everything goes fine, loads the site, gets the data, and is working. Great. So now, in the real world, we're going to say, well, we need to make some changes in this model. So we need to change this data. But we saw before that if my model doesn't match my database, if I change anything here and then I publish, it's going to break, right? It's going to say, something doesn't fit here. And I cannot just delete the database like I did before and just recreate it because they're going to lose the data. So how do we do that? There is a way, so when we use entity framework like we're using here, we can do this little command called enable, enable migrations. So migrations is this little thing that entity framework does that it allows you to control versions of changes. And this is giving me an error for a good reason. It's telling me I have 2 different database contexts. One that's created basically to manage users and identities. So one of the cool things about this new version of ASP.NET is all the authentication, user management, and permission management can be done at the database level, and I have model classes for it. So I can remodel that the way, if I say, well, I need to know the user's country, or I need to know the user's whatever ID or whatever, I can manage those properties. But in my case, I don't want to manage migrations for that. I actually want to manage migrations for the models for this trivia application, the questions and answers and everything. So I need to actually be more specific. I need to say, I actually want to enable migrations for this trivia model classes. So I'll run this. And this time it shouldn't complain anymore and should enable migrations. From that point onwards, I can control I can start versioning my changes in the database. I can even give labels to every change I make. And Visual Studio will be smart enough to actually help me to control which versions I have locally versus which versions I have in my database and apply the differences until those versions match. So how does it work? When I enable migrations, it creates this initial create class. And this initial create class takes a database that's completely empty and creates this basic model that I have. So it says, okay, app methods create a table with these columns, with this primary key, this foreign key, then creates this options table, and then this trivia questions table. It sets everything up, right? So that's going to run if it realizes that my database doesn't match what I have. And of course, there's the down method, which is if I uninstall this version, it's going to delete these things. And that's you got to be careful with this, right? Because you have to really think, what are the actual scenarios where I would uninstall something like that? Is that how it would operate? Maybe a safety measure is just delete this, right? Because it's very unlikely you're going to have this, right? More likely if you're people ask, but how do so I install something, it breaks. How do I uninstall it? You probably don't uninstall it. You probably create a hotfix and install on top of it, right? Because that's how the real world works, right? So be careful about that. But anyway, so now I will go to my model classes and I'll make a change. Let me build it first, because I think if I don't build, it will start breaking. So I have my trivia question class, and I'll create a new property here. I'll say whatever public string hint.
right? So now I have this new property called hint. So whenever I present a question, I will give you a little hint so you maybe can guess what the answer is. That's a new change. So I will create a label for it. I'll call it add migrations. Right? I'm just saying this is a new change, and I could group several changes into one label. In this particular case, I'm doing one little change and putting a label on it. So what it will do is actually create a new file in my project with this particular change. Oops, I think it's add migration. There we go. What happened? Remember I had the initial create class? Now I have a new class called added hint, right? What this does is adding that column, right, of type string. And if I uninstall it, it drops the column. So again, work out your deployment process. Like, are you ever going to uninstall this feature? What is the... If that column had data and then install this feature, that data is lost. So what is it that you actually want to do? You can even add, I could, for example, add some data. Imagine you're adding a table called countries. You probably want to pre-populate that with countries, right? So you can do that here as well. So when the feature is installed, you're making some data changes and you're actually adding data into those tables. So that's also possible. If I run this locally now, it will break because it will look at this change I've made and it will look at my local database and say, those things don't match, right? I don't know how to work with this new property you gave me because your database doesn't have that. So if I want to apply these changes, what I will do is I will call update database. Now it will looking at, well, I know your database is this version. I know you have these changes to make, so I'll apply them right now. And now your local database has all these things that you asked me to do, right? But what about if I'm publishing this to Azure, right? Those changes are not there yet. So when I publish my site again, I right-click, publish. So it already knows, right, because I published before, it knows the website, it knows the database. I can actually click on this little thing here and say, first time this application runs after you deploy it, do that check. Look at the database, look at the changes you have, and if they don't match, apply them. Make it so the database has the same version as this binary is looking for, right? So that way I have control to say, this new binary will make this database match the version and both will be applied, right? So just to try that out, I'll just publish that. Might take a little while. While that happens, that's actually fairly quick this time. That's good. So, and it loads. You see that it's taking a little while, right? It took a little bit longer than normal. That's because it applied those changes to the database, right? So of course it won't apply 2 times because it will look, when you see what it does at the database, you see it creates a few tables there. And those tables are for controlling the versions and what has been done. So it knows it doesn't have to do it twice, right? You'll be smart enough to know that. So that's a way you can actually manage database changes with Entity Framework. Do we have much time? No, we're running out of time. So quickly, two things I wanted to show before we finish. One, probably my favorite new feature on Azure is how you can control multiple instances for what we call deployment slots. I can create multiple deployments of the same site in multiple slots and swap them, right? Imagine you have a production site and you have your test site. Then you deploy a new version in your test site. Production still has the old one. When I'm sure this one is good and works, I can swap them. And suddenly your test becomes production, your production becomes test. And now I can deploy the new one on the new test site. And that's so easy to do. let me just show that before I talk about Git. If I go to a website, and that's stuck here for some reason. I think it's because I'm debugging still. Nope. Cancel. Okay. So if I take any Azure website and I go to the dashboard, no, here, I can create a new deployment law, right? And I just give a name to it. I can call it, for example, my test. What it does here, it's creating a complete copy of that website, and actually it shows in a different way. It shows as a sub-node of that site, right? And what I can do now from Visual Studio when I deploy, Visual Studio asks, do you want to deploy to that one or this one, this little copy? Right? At this point, both are pointing to the same database, but I could control that. I could point one to a different database, so I want to make changes and not break them. Depends on what kind of tests you're actually running. Do you want to test on the real database, or you want to test on a separate database? If you're doing the entity framework migrations like I did, you probably want a different database, because if you point both to the same database and you run the test, it will change the database, and then the production site will break, right? So be careful with that. But anyway, now that I have these two separate sites, I have an option here. No, I got to get inside it first. I have swap, right? And what swap does is saying, change this with this, right? Get the test one, get the production one, and change them. So this is really cool, because what this does is creating a simple process for you guys where I was drawing this to make it easier to explain. Where is it? There you go. Where basically you deploy to this test or staging. You can optionally point this staging to a separate SQL Server that you can test and mess with it and break it. When you're sure about it, you can point it to the actual SQL Server in production, and then you swap them both, right? And now that staging becomes production, and the production becomes staging. So next time, what are you going to do? You're going to deploy the new one to the staging again, right? Point it to test stuff, point to production, swap again, and you can keep on that cycle forever. Like you can maintain your site that way. So it's really, really cool. Likewise, you can create backups of your Azure website. So if you mess with something, if you break something, you can have automated backups, both of the binaries and the database. So you can always restore. So if you go to Manage Portal, those features are very easy to access from there. You can always say backups, right? And you can configure automated backups. You can tell in which storage account you want, when you want it, if you want to include databases or not, right? You can do backups right now or in an automated manner, and you can restore them. The problem with backups is when you're restoring things, it takes a while. It's not like swapping that's instant. A restoration of a backup takes a few seconds, maybe minutes, depending on the size of your database. So you don't want to use that as your recovery straight to your website, because it will go down for a few minutes, right? So, but you can restore to a different site. So I've made a backup, then I restore to a different site, I fix whatever that I broke, and then I swap it back to production. So you can do that as well, right? I'm finishing here because we're running out of time, but the only thing I didn't show that it's also an option. How many people here are using Git? Use Git as a source control? Cool. So you can map your website to your Git repo, and every time you push a change, you're actually pushing to your website, right? It's actually, you're deploying it to Azure. And the cool thing about it is that every deployment becomes a new deployment here, and you can roll back, right? You can pick a previous version here, say, put this one back there, right? So it will know how to do that for you. Again, careful with what you do with your database, because your new deployment made a change in the database. Now you say, oops, I want to go back to this previous version. That's all great, but what are you going to do with a database that has changed, right? So my perspective on this is great if your database is not changing a lot, right? Or almost never. If your database is changing a lot, you probably need to actually create a hotfix and deploy the hotfix, right? That's an easier way. I think I mentioned everything I wanted to mention, but do you guys have any questions? Anything you want me to show in more details?
About the up and down levels of the database. So
Yeah.
that automatically
Up and down levels.
somehow when you make the data migration.
Oh, sorry, the up and down levels. Okay,
Yeah.
the migrations. Yeah, so the up is automatic, which means I deploy the new binary.
No, I mean the code, the actual code lines, like add code, so you have to write those.
Oh, no, so this is generated automatically. So, yes, so you saw that I created a new column. And when I say add a migration, it look at my model, it compare with the model we had before, say, you create a new column here. Okay, I will create a method for you that does that. So that happened automatically.
That's magic.
Yeah, that's magic, right? But normally what people do is like they change this. They add a little bit more stuff because there's always something else you want to do. I want to change an index. I want to change so you're free to do whatever you want here, right? As long as the final result matches your model, right? What happens a lot is a common support request we get is people mess with this, right? And then that method doesn't create a database that matches the model they have. And then they deploy, it broke everything. So, yeah, right? So careful with that, right? Any more questions?
I have a question. Can you show that picture where you had those like
Sure.
staging and the other?
Of course.
So
This one.
you mentioned that, for example, if the database changes, so then first you would test it on the staging,
Yeah.
and then you would switch to the production database,
Yeah.
and then start the portal.
Yes.
But when is the actual migration changes running?
So the actual migration runs on the first request that's sent to that site after deployment. So the first time you call a ASP.NET site, it calls the application start event.
Okay.
So that we run just once, right? And the application start will actually run this migrations code, and we'll look at the database, we'll look at what you have and say, okay, I need to install these and these and these on the database.
Okay, but so first we would when you want to test it,
Yeah.
we would it would be first access on the staging machine,
Yeah.
and it would do the database changes in that test database.
Yeah, so you have to be careful with what really matters here is your database connection string. So when you deploy to your test, make sure your connection string is not pointing to production, but pointing to your test database, right?
Okay.
So then you can,
run the migration in the test database.
yes. So it's,
Then do it done in the production.
when you're done with this, then you're going to point your connection string in staging still, you're going to redirect your connection string to production,
Yeah.
right? And then you have two options, but my preferred option is you just swap. You don't do anything else. You could change your connection string, then you swap. And then the first guy who hits that site in production now will trigger the change in the database, right?
There are some options with this,
Yeah.
like the NuGet gallery site, NuGet.org actually uses migrations, but they don't rely on that. They actually have code. They go into a console and trigger migrations. So there's an API, because you may want to actually control that. You don't want to just have whenever a random guy browses the site, you may want to.
That's what I
Yeah.
thought. That when is this actually happening?
You can make it manual, yeah.
And you can also generate SQL scripts.
Yeah.
So you can go through, do the migrations and generate the SQL scripts, run those in an offline database, or you know what I mean, control that, because a lot of people want a version using the SQL scripts. You can do that too.
Yeah, because like we get that a lot. Like people say, we don't use this entity framework thing at all. We use story procs. We have our way of managing databases. You can still apply exactly the same principle with your own scripts, right? And manage your version, your database yourself. It's just that's more work, but you can do that. Right? Good. Thank you.
Excuse me.
Yeah. Oh, sorry.
So how do you do this site under maintenance?
The site.
Under maintenance.
Put a site under maintenance.
If you are doing deployments to production, and it takes a lot of time.
Right.
So we have to
Well, and so, yeah, exactly. So because it takes time, so what we do is like we're creating this deployment slot. So this is, nobody can see this but my testers, my guys. So I can bring this site down, I can test it, I can break it, I can mess with the database, right? Nobody here is noticing that because they're calling this site on that database, right? Only when I'm sure about it is that I make this switch. And so the trick is when that switch happens, I can either do it manually, but then I will have some downtime because now I'm saying I'm bringing the site down, I will run a bunch of scripts here, right? And that might take a few seconds, a few minutes, depending. And then I'm swapping this thing, and then I bring it back up. So I'm getting a lot of control, but I'm losing some downtime because of that. The other option is to say, no, I trust blindly that Entity Framework will do that for me. So when that swap happens, which is like a fraction of a second, the first guy here who accesses this thing will trigger that change in the database, and nobody will notice that a change happened. It might be just a little bit slow, but will happen, right? So it's a trade-off between I accept some downtime versus I don't accept some downtime, but I trust Entity Framework will do everything for me. As long as you really deep test a lot this, then you're sure that actually happens, right? So, yeah. Cool. Sorry, I took some of your time.
This is very useful stuff, right? Let's take a 10-minute break and start at 35 after.